Now the official welcome to this webinar hosted by DVDH, Invest in Denmark, Renewable and Fjernvarme Fyn. It's a webinar about renewable heat in Odense. Odense is the third largest city in Denmark, maybe the fourth. I'm actually not sure right now. Never mind. And they have a large district heating system. Facebook is building a data center down over there, and already now they are constructing a heat pump station to benefit from all the heat coming out from the cooling of that data center. We have three excellent speakers today. The first one will be Kim Winter. Kim Winter is from Fjernvarme Fyn, a district heating company in Odense. The next one is Anders Kari from the consulting engineering company Renewable. And finally, but absolutely not least, Kim Schulz, who's a special advisor at Invest in Denmark. During the session, you're most welcome to raise your hand. I saw you do that just a minute ago, Max. But even better would be if you write in the chat function questions, comments, speak up, slow down, things like that. I will then organize, as the moderator I've been asked to do. By the way, my name is Morten Hjort Dudal, and I'm from DVDH. I'm Business Development Manager here. You can see me at the top of the screen now. Ask questions in the chat, but you will also have a proper panel discussion in the end where I have prepared a few questions, and hopefully you have also during the session prepared a few questions, so there we'll have an interaction between the three speakers and me on the topic. So enough said from my side. Now Kim Winter, who is Head of Business Development at Fjernvarme Fyn, and his primary focus is the green transition of their district heat production. He will present the strategy and the commercial aspects of their surplus heat project with Facebook. So Kim number one, we'll have Kim number two later. Kim number one, unmute your phone and go ahead, please.
Thank you very much for the word. I hope everybody can hear me now. I'm heading business development and Fjernvarme Fyn, and I had the pleasure to work with Facebook on this project. We had a very constructive dialogue on how to get this project up and running. There has been a lot of commercial work and a lot of design work, and I'll get around some of these issues just to let you know some of the challenges we have been through. So in my presentation, brief, however, I will give you an introduction. I guess some of you might not know the framework in Denmark, so I'll give you a very brief introduction to some of the targets and framework in Denmark. Also give an introduction to Fjernvarme Fyn and some of our main challenges with phasing out coal in our green transition. Then I'll move into what is the elements of our green transition, how do we think the heat pumps in our overall production mix, and why is waste heat or surplus heat from Facebook, among others, a very important part of this. And then finally, but not least, I'll dive more into the specific project with Facebook and let you know a few more things here. But also you'll get some more details from Anders later on the project. So first of all, a few things about the Danish targets. So we have, I believe, the highest carbon reduction targets in the world for the whole community of Denmark or society of Denmark to reduce the carbon by 70%. And actually the climate minister said that when they made the target, they didn't know how to realize it. They could maybe make 60 or 70, 65%, but they wanted to really make a stretch target. So everybody has to chip in.
Sorry, you have to speak a little bit louder. You're a little bit difficult to hear, so speak a little bit closer to the microphone, please.
Okay.
Not too much, give it a bit more.
I'll move the microphone a bit closer on. I hope this is better. So everybody is chipping in the Danish energy sector, and especially from the district heating sector, we believe we could make a zero, at least zero coal in 2030, and possibly also a zero emission completely from this sector. So some of the targets or some of the measures that has been taken into play here is that a lot of wind and solar power will be introduced, and as we're not so much fond of biomass anymore, subsidies will not be as high for biomass anymore. So it has to compete with wind and solar, which is approaching a zero subsidy. So there's a lot of focus on electrification of the heating sector, how to store the energy, and especially how to use as much surplus heat as possible. Unfortunately, there's been an attempt to simplify the tax on surplus heat, and it has maybe made it a little bit worse, but it's still a suggestion. So we hope that it'll be modified, so we will still have the possibility to use as much surplus heat as possible. So a few things about Fjernvarme Fyn. We are, as you mentioned before, the third largest district heating company in terms of energy and turnaround. When you look at our grid size-wise, I'm told it's one of the largest because we have these more than 2,200 kilometers lines in the city. So the temperature is quite low. It's around 70 degrees to the households, which also makes it more interesting or possible for heat pumps to be introduced in our system. And just to touch upon some of our overall targets now, it is to remain in the lowest price range compared to other district heating companies, and then at the same time to phase out coal. So looking at our challenge, you can say last year we had more than 300,000 tons of coal in our production. We had a quite varied mix, but still coal was about 1/3 of our mix. So we have made a lot of work on scenarios and project development on how to substitute coal with something else. And of course, heat pumps is the main component here, and some of it will be from ambient energy sources, and a large part of it would also be from waste heat from data centers, could possibly be from greenhouses and other industries. So in 2030, we expect our production mix to look like on the right side of this picture here, where you can see electric heat pumps, industrial heat. These things will be about 30% altogether. This is how we like to illustrate our concept, where you can see on the left side our existing units. Let me see if I can find this here. So these are all our existing units. We have the large coal-fired units, which we expect to convert to gas for an intermediate period to phase out coal very soon. Then we have our waste unit, our straw unit. These will all exist for a long time. We will introduce possibly a new small wood chip boiler, and then a lot of heat pumps in the system. Some of them fed by energy from the sea, some from the air. Electric boilers to take some of the peak from the surplus power in the grid. And then also the Facebook waste heat we will introduce in here. Actually, now the pumps are being commissioned as we speak, and I'll show you a few photos from the project in the end of my presentation. And then there's another interesting project here where we utilize heat from a sewage facility in town. So, and then when you have so many heat pumps, we need heat storage as well to utilize the heat pumps when the power price is as low as possible. So
Kim,
getting
sorry, before you're getting any further, there's issues with the sound and a few people. Kenneth, can you hear me now? Hans, can you hear me now? Søren, can you hear me? Please type something. I'm really sorry. There's people who can't. Very, very weak. Seems like nobody else is having that. Multiple attendees are typing now.
Okay, I should be standing more or less on top of my microphone.
Yeah, I can hear okay in Abu Dhabi. Yes. Okay, let's continue. I'll just
Yeah,
1 second.
I'll take the microphone to my hand now. I hope that's better.
Even further up here, you have to make sure this is the right one. Kim, some is hearing pretty good. Okay, I think the system is working. Kim,
Okay.
Go back one slide, pick up where you ended, and please continue.
Would you like me to repeat this slide?
No, just the few last remarks you had.
Okay, so just overall, you can say we have a large system with a lot of units where we have a synergy between the thermal units here and where the thermal units will work together with the heat pumps and electric boilers. So we have an optimal utilization of all the technologies in our system. And a lot of these has already been built or under construction. Okay, I'll move on to the project with Facebook, where we started the whole process all the way back in 2015, even before I worked with Fjernvarme Fyn. The very early discussion started on how should Facebook be supplied by heat, and how could they get the power from the grid, and how could we utilize the heat. So there's been a long stretch to get where we are today. But basically, when you look at this concept, you can see that Facebook, let me see if I can find the arrow here. Oh, I can't get the arrow right now. It's not moving. Anyway, so Facebook is, of course, owning and operating the whole data center. We have nothing to do with that. It's all driven by renewable energy from a wind farm. We own and operate the district heating plant with the heat pumps, and our system limit, you can see system barrier limit, is right in the middle of their data center and our heat pump plant. That's where we take the heat from them. Anders will get back to some of the technical stuff later on. We have an agreement where we will get 100,000 megawatt hours of surplus heat from Facebook, which is giving to us free of charge. Then, of course, we have invested a considerable amount in 25 megawatts of heat pumps that can utilize that. And so we can substitute a large amount of coal in our system with this. It's as we speak now, it's being commissioned, and Facebook has already commissioned their data center about a month ago, and we will very soon be commissioning or opening our plant as well. So this is just to give you a slight idea of some of the things that we have worked with in the process. So first of all, you can say in the initial dialogue, of course, Facebook was interested in coming to Denmark because there is a high security of supply in our systems. There's a high amount of renewable energy in the system. There's a well-functioning infrastructure and also district heating, so they can have a high energy efficiency on their concept. And also in that early stage, you can say the municipality and also Invest in Denmark, which we will hear from later today, was very active in getting us, you can say, in a good dialogue with Facebook. Then I just marked a few things which I think was important to mention. Then in regards to the analysis phase, of course, it was important to find the right concept. What kind of heat pumps are we looking for? How should we cooperate? Will they be giving us could they be giving us the heat for free as they intended to do? Could we take it? And these things had to put those things into the business model. And then especially in Denmark, the regulatory system, we don't believe was all that ready for this kind of surplus heat project, because usually surplus heat is taxed in Denmark, and what is taxed is the fee that we should be paying for the surplus heat. But as we're not paying anything for the surplus heat, we luckily didn't have to pay for a surplus heat tax. So there was a few things here, and also was it a cooling project, was it a heating project, some of these things. And then as we are not allowed to make money as well in a Danish district heating company, of course the business case should be balanced. Then in the maturation phase, of course, we had to look more into especially design. How should the heat pumps be constructed? In our case, we have 9 heat pumps, which are situated in groups of 3, and so they lift the temperature in 3 stages, and that's the way to, in our case, to get the highest efficiency. And then right now, you can say we're in the commissioning phase, and as this is the largest surplus heat project from a data center, of course, there's a lot of eyes on us. How is this working? And we, of course, then very focused to get everything up and running as soon as possible. So we hope to very soon to be able to invite you to an opening at our site. So these are just a few things I'd like to mention from our process. It's a long process. Finally, you can say, why did it make sense, this cooperation between Facebook and us, and why did they situate their data center here? And one of the main reasons, you can say, is a big data center need a high security of supply for the power. So that's one of the main reasons. Then you can say, why has it been possible to make a good project with us? It's because they could be situated in our distribution grid, where we don't need to feed the district heating in for more than 70 degrees. So we don't have to push the heat pump so high. So we can make a good efficiency. There's good space and good data connection to in this area. Finally, I'd like to show you a few photos of the area. As you can see, the heat pump is. We even had an architect on the plant, so we think it looks very nice. And as you see on the picture up on the left side, we have a visitor center as well, where we can show to the world how we have done this. And if the heat pumps are running and there's a lot of noise, we can look through the window, which you can see below in the visitor center. You can look to the heat pumps, and then on the right side you can see some of the 9 heat pumps that are being situated in the plant. So that's what I'd like to tell about the project, and of course I'm happy to take questions later on. I better get the floor now to the next speaker.
Thank you. Thank you very much, Kim. Really interesting. And thank you for the invite, by the way. I'm pretty sure that all 70 plus people here are ready to come and visit you during the opening. And I think we are all also very interested in visiting you a year later when you're getting data. No, Facebook have the data, but when you have numbers and data on the system you have operated for a year, we look really much forward to that. I hope you can share that in some of our other LinkedIn and hot cools and so on. I have a few questions for you, but I will save them for the for the panel discussion. Now I would like to hand over the word to the next presenter, And what I forgot to do early on was I should have reminded you, here's a nice picture of Kim, and the next one is Anders, also a very nice picture. I should have reminded you that we are recording this session, so if you don't want to be on it, tell us, then we'll take you out of the recording, and the recording will later be used on all the platforms, social media platforms you can imagine, so that it'll be shared. Again, in the end, if you later share in the end of this presentation, you can share your email address and we will send everything to you. I'll also give you a little cliffhanger. I think that's important. If you stick with us for the whole time, I think there's no need for a cliffhanger, but if there should be, I'll ask the three guys how to get started. What is the key thing to get hold of to make such a project work? Well, enough said. Now Anders Kari is the next one. Anders is a mechanical engineer, experienced with design of refrigeration and heat pump systems, and he works with district energy at the consulting engineering company Renewable, where he's a specialist in district cooling and heat pumps. And he will talk about some of the more technical aspects of the heat pumps. And now I rely on all the more technical persons among the audience to help me with a few questions, because I'm not technical. But never mind, you may be. Anders, please go ahead and talk to us. Give us your presentation.
Thank you, Morten. I hope you can all hear me now.
Loud and clear.
All right, perfect. Yeah, as you said, I will talk about the design of Fjernvarme Fyn's heat pump plant and finish the presentation with some of the main takeaways from this experience. My task in this project has included providing technical expertise on heat pump systems and also conducting supervision during construction and commissioning. The project here has been really interesting to work on due to the size of the plant, as well as the integration not just with the district heating system, but also Facebook's waste heat recovery system. I'll start with a brief overview of the project here. The waste heat recovery plant is one of the largest waste heat recovery projects in the world that uses heat pumps for district heating. The plant has been prepared for a phased construction where the capacity can be increased as required at a later stage. The data center itself consists of two large buildings, each of them around 26,500 square meters, with a possible future third building of 39,000 square meters. The two buildings consist of 4 internal data halls with equipment for waste heat recovery, and also their own independent cooling system. Renewable has been the owner's engineer for Fjernvarme Fyn on this project since 2015 and still working on it today. We started with feasibility studies of different heat pump solutions and designs, and then later we completed the concept and the more detailed design for the building and the heat pump system. We also assisted with the tender process and have helped develop the control strategy in collaboration with Fjernvarme Fyn and Facebook. And finally, over the last year and a half, we have supervised the project on site during construction and commissioning. Looking at the overall system design, the plant is connected to 2 separate closed-loop water circuits. On the right-hand side here, the heat pump plant is connected to the waste heat recovery circuit, where the heat pumps produce chilled water that is distributed to Facebook through large underground pipes. At Facebook, the water runs through chilled water coils that cool down the hot air from the servers, and this process then heats up the chilled water before it's returned back to the heat pump plants. On the left-hand side, the heat pumps will then deliver the recovered waste heat at higher temperatures to Fjernvarme Fyn's district heating network. The heat pump system itself consists of 3 parallel groups. The 3 groups are almost identical, except that one of the groups is supplied with variable speed drives, which allows for greater capacity control. And meanwhile, the other 2 groups consist of fixed speed machines that will operate with a slightly higher efficiency during full load conditions, which we expect to occur most of the time. Each of the 3 groups has dedicated circulation pumps on the waste heat recovery side and the district heating side, which ensures accurate control of water flows and temperatures. With this particular design of the plant means that we can regulate fully between 10 and 100% capacity without significant reduction in efficiency. And at the same time, it guarantees a high security of supply since a component failure in one group will not affect the other 2 groups. Looking at the waste heat recovery circuit, there's the buffer tank here, 75 cubic meters, and the tank divides the waste heat recovery circuit into 2 separate hydraulic systems, the production system on the left and the distribution system here on the right. On the production side, the circulation pumps are regulated by flow meters on each heat pump group, while on the distribution side, the pumps are controlled by differential pressure transmitters at Facebook. This will ensure that each of the chilled water coils receive sufficient water flow. The buffer tank will then absorb the flow differences between the distribution and the production sides and make sure that the plant is not affected by any sudden changes in the system. The tank also means that Fjord can provide chilled water for brief periods in case of a component failure before another group can ramp up. Now, moving more into the technical side of the heat pump units, as Kim said earlier, there's 3 ammonia heat pumps per group with a total of 9 heat pump units. Ammonia was chosen as the refrigerant due to its superior energy performance and also due to Danish restrictions on synthetic refrigerants. All the units are single-stage screw compressor systems with economizers, and in this instance, screw compressors were the most feasible solution due to the size of the plant and the expected operating pattern. The screw compressors are almost the same, which then reduces the amount of spare parts required for the plant. The heat pump units have been supplied by Johnson Controls and were manufactured and performance tested at their factory before being delivered to site for final inspection. For final installation and commissioning. On each heat pump group, the water on the waste heat recovery circuit is chilled in 3 stages, and it's also heated in 3 stages on the condenser district heating side. This 3-step principle reduces the lift between the cot and the hole side, which then improves the efficiency of the heat pump system. The compressors can regulate their capacity, which will ensure that the chilled water supplied to Facebook has the correct temperature. The 9 heat pumps that have been installed at this stage can deliver around 25 megawatt of heat, which is just under 3 megawatts per heat pump. On the waste heat recovery side, the water is chilled by 10 to 12 degrees through the heat pumps before it is pumped to Facebook. On the district heating side, the return temperature varies between 35 and 45 degrees Celsius, depending on the time of the year, but should usually be around or just under 40 degrees Celsius. The supply temperature for the heat pumps is between 70 and 75 degrees Celsius, depending on the district heating requirements. The design COP for the heat pumps is around 4.8 if the supply temperature is 75 degrees Celsius and around 5.2 if the supply temperature is 70 degrees Celsius. This means that for every unit of electricity that the heat pumps consume, they will produce around 5 units of heat. And the COP for this particular plant is around 30 to 40% higher than what could be expected from a similar air source heat pump. Each of the 9 heat pump units have their own separate ammonia circuit, and the ammonia charge per heat pump is around 275 kilograms. This is less than 100 kilograms per megawatt of heating capacity, and this relatively low ammonia charge is an important safety factor or safety feature of the plant. One of the more interesting tasks on this project has been the system integration and the collaboration between Fjernvarme Fyn and Facebook. Because unlike a lot of other heat pumps, the system is not just integrated with the district heating network, but also Facebook's waste heat recovery system and the data center operation. And it is important for the data center that the system is reliable, even though they can revert back to their own independent cooling system. The heat pumps will provide baseload heat for Fjernvarme Fyn and run at full capacity for most of the year, but there may be some periods with reduced capacity. This means that the operating pattern is primarily determined by the district heating demand, and this again underlines the need for Facebook to have their own independent cooling system. Fjernvarme Fyn and Facebook have their own control and monitoring systems that are continuously communicating with each other. For example, Fjernvarme Fyn will send a startup request to Facebook when they want to start the plant after a period without operating. When Facebook then accepts this request, a series of events will take place before the heat pumps can start. This includes opening motorized valves and flushing the waste heat recovery circuit, since there might be large temperature differences in the overall system. When the plant is in operation, Fjernvarme Fyn will send a capacity request to Facebook, essentially asking to recover a certain amount of waste heat. And this signal exchange will also show how much heat is currently being recovered, and Facebook can use that to plan their operations. The two CMSs can also send alarm signals that will ensure that both Fjernvarme Fyn's and Facebook systems can shut down safely if needed. So one of the key takeaways from this project has been to design a system with a certain amount of flexibility, because the different heat pump suppliers can offer different solutions that can achieve similar results. Therefore, it's important to make a design that allows them to offer the best and most efficient solution within the functional requirements and within the equipment that they can offer. Also, the temperature difference and the temperature lift between the waste heat recovery side and the district heating side will have a big impact on the system's performance. That might not be a big surprise, but after all, it's still a very important area to focus on. And finally, it's very important to be prepared for close collaboration between the district heating utility and the data center to ensure that the system lives up to the expectations of both parties. So that was the end of my presentation. Thanks for your time, and back to you, Morten.
Anders, thank you very much for a very interesting presentation. Hardly technical, but I think I understood a bit. So you're a great presenter, I can tell you. Again, a few questions later on in the panel debate. I will ask you about what Facebook think about risk on in cooperation with such a district heating company like yours, but we can answer that later on. Now it's time to continue to Kim Schulz. You already unmuted yourself. I will shortly here now just give you a picture of Kim. Are you Kim? Here you are. And Kim is a special advisor at Invest in Denmark. That's the Danish National Foreign Direct and Promotion Agency, meaning he helps foreign companies to establish themselves in this wonderful country as we are. And Kim has been part of the Invest in Denmark's clean tech team for the last 5 years. And he will share his comment on data centers, but what he has seen is that there's a global demand for data center capacities rising rapidly, and they also want to become more green. Give me a second, Kim, and then you have your slide set right in front of you.
Thank you very much.
Go ahead.
Thank you very much. I hope you can hear me, all of you, and I'm the second.
Kim, you need to speak up a little bit more. Keep your phone or your microphone closer to you.
Okay, is it better now? I hope
a bit, but even more maybe.
Okay, I hope it works better now, so you can hear me. Is it okay now?
Speak up, and then we go ahead. Yes.
Okay, thank you very much. So yes, I'm Kim from Invest in Denmark, and on the first picture here, you see the Facebook data center in Odense. We had the pleasure of facilitating meetings between Fjernvarme Fyn and Facebook about the waste heat opportunities. And we also had the pleasure of introducing Facebook to the waste heat opportunities in Denmark and our district heating system, which is quite unique. So let's talk about data center demand. So this slide shows one prediction of how the data center capacity demand is growing globally. So there are different predictions about this, but the fact is that it is growing quite a lot every year, more than 10% every year. So that also requires a lot of power to power the servers of the data centers globally.
Kim, you have to speak up. Sorry.
Is it better now?
Yeah. Shout as loud as you can. Go for it.
Okay. I shout as much as possible here. So this slide shows the energy consumption of the data center. That's again a prediction, and the green figure is the energy consumption of the data centers. So that's a lot of power being consumed to run the servers, and all that power also generates a lot of waste heat. So the amount of waste heat is also really increasing globally. And in order to meet the carbon emission requirements globally, it's a very good idea to make use of the waste heat. That's what we are trying to do here in Denmark. But what is actually going on in Denmark in terms of the data centers? So we have had several projects in Denmark with hyperscale data centers and also smaller data centers. So right now we see in Denmark that Apple is constructing a big data center in Jutland near Viborg. Google, they have 2 sites in Denmark, and they're building at the first site in Fredericia. And then Facebook, they put their data center into operation just 2 months ago. And we have companies like Digiplex from Norway, who started operating in Copenhagen and have announced that they are going to expand in Denmark. We have another Norwegian company, Bulk Infrastructure, building a data center in Esbjerg. And we have companies like Interaction and Global Connect, who have been operating in Denmark for many years and are expanding. And at Invest in Denmark, we do have a lot of requests concerning site opportunities in Denmark. So this is something that is really moving on. And why do we have this interest in Denmark from the data center operators? I think Kim Winther already mentioned that power availability and reliable power grid is indeed very important for the data center operators. In the Nordic in general, we have quite competitive power prices, especially for industrial consumers. And we do have a lot of space in Denmark. We are approximately the same size as the Netherlands, but only 1/3 of the population of the Netherlands. So that means a lot of space at low prices. And then very important is that actually we are quite quick in terms of providing building permits in Denmark compared to other countries. So we are number one in Europe. That's measured by the World Bank. And of course, the cool climate, it's nice for the data centers in terms of energy consumption, and our green agenda in Denmark, which was already mentioned by with very high targets. And there's also a lot of opportunities for the data center operators in terms of adding to that green agenda in terms of power purchasing projects, like we've just seen Apple has been doing. Google has been doing that. And
you're fading out again. Speak up, please.
The waste heat. So in Denmark in general, we have the pleasure of having the largest district heating grid in the world compared to the population. So 64% of all Danish households are heated by district heating. And we have seen that from the Facebook case that the waste heat from the data centers can be used for district heating. And of course that's a very important part of the green agenda and can really increase the overall energy efficiency everywhere it's being put into operation. You already heard a lot about the Facebook the Facebook solution. I think what I can add here is just that the power that is driving both the data center and the heat pumps is of course renewable power. So it's a kind of double green solution. All the power is renewable, and we make use of the waste heat and reduce the heat, the fossil fuel consumption for heating. But we're also seeing some new trends in the data center business. So far, the hyperscale data centers, or most data centers in general, have been air-cooled. But now we see that different kind of applications like artificial intelligence and high-performance computing is generating so much heat, consuming so much power per server that liquid cooling actually makes sense. And that certainly also makes sense in terms of utilizing the waste heat. Because when you have the air-cooled solutions, where you have the hot air coming through and the heat exchanger, then you obtain water temperatures around 25 to 30 degrees. But if you have a liquid-cooled data center, you can actually have heat coming out from the data center to the district heating companies' heat, which is approximately 55 or 60 degrees. And that really generates a very nice business case, both for the data center operator and the district heating company, because you don't need that large investment in heat pumps. So actually that makes it possible for the district heating companies to pay for the waste heat from such data centers. So we do think that we are going to see quite a few liquid-cooled data centers in Denmark in the future, because there's also a profit here that you can generate. But of course, the district heating systems, they are about heating houses, especially in the winter time. There's not a lot of heat consumption during the summertime, so of course we also have to think of other ways of utilizing the waste heat from data centers. And actually there's some projects and research going on in different parts of the world. So you could perhaps use waste heat for greenhouses, you could perhaps use it for algae farms, or for fish farms, drying of wood chips and other biomass materials, and even for things like heating very large-scale outdoor swimming pools and things like that. So we also hope that there will be some opportunities to use a lot of waste heat during summertime. But overall and in general, Denmark is certainly a hotspot, so to say, in terms of utilizing waste heat because of our district heating systems. And at the same time, we are attracting data centers because of the green power, which is very reliable and at very low cost. And we also, in terms of liquid cooling, we do have a lot of opportunities of providing technical water for liquid cooling. So that's definitely very feasible in Denmark. So yeah, so that was actually my conclusion for this presentation here. So we do hope that we will see many more data centers in Denmark and also data centers with liquid cooling. And we from Invest in Denmark would be very pleased to talk to everybody who have thoughts about building data centers in the northern part of Europe. And we are available for consultation, and we are also available at the Data Cloud Nordic event in Copenhagen on the 3rd of December, where you could come and talk to us and discuss the opportunities. So thank you very much.
Okay, thank you to Kim. We'll now continue into, where are we? We are here into, soon we will have a panel discussion. Now you see a bit of a different slide set or different layout here. We would like you to give us a short vote on what did you feel about it until so far. Oh, 2 found it was very great. Thank you very much. By the way, that is the right answer if you're in doubt. Also, you'll see above that one here, just above that one, if you want to have, and Ye Oha from Ramble have just answered that he would like to have more information. If you type in your email address there, we will send you the links. We will sign you up for we will share other information materials with you. We will sign you up for Hot Cool. Always. Leave again if that's what you want. So put in your emails, then you'll be updated on everything. And now we will, this will stay. We'll go on to this where we have the panel discussion, and I see there's already some questions. I will start by asking the 3 speakers. You have touched on it, but what is the most important thing that you should consider when you start this whole process of getting heat from a data center? What is it the data center want? What is it the district heating company wants? And where do you meet and how do you discuss these things? I think it will be interesting to start with you, Kim Winter from Fjernvarmesyn. Give us a few hints to how you actually did that. And I have unmuted you now, so go ahead. And then Anders, start preparing because you'll be next. Kim, go ahead.
Yeah, okay, thank you. So first of all, I think it's important to have a good, what can you say, match in between the district heating company and the data center. What kind of portfolio does the district heating has? Is it something that needs to run all the time? Can it fit in the surplus heat? Because if you already invested a huge amount in something else, you might not be open to give this surplus heat a whole lot of production hours. So a good match, I think, is very important. Then also you can say what has been the success factor in our project is the very early dialogue and the common goal. It's something we both wanted to do. Facebook wanted to give this heat away for free and to have it reused as, of course, also part of their, you can say, green story, that this is a renewable energy and it's actually used twice. First in the data center and also in the heat pumps, and then substituting coal. And also at the same time, we had this goal that we needed to substitute coal as well. So we had a very good match there. And the early dialogue, you can say, is important to figure out what is the system barriers, how do we interact, what kind of investments are they doing, what are we doing, so we don't make redundant investments and they don't set up a system that we're not able to work with. So those kinds of aspects I would mention.
In this dialogue, you said it needs to be. You started out saying that this needs to be I think you used the word a good relationship or something, where you have an open discussion where you can actually discuss different things. Did you have in-depth discussion of what kind of risk they can handle, which kind of risk you as a district heating company can handle, which kind of investments you would like to do, and so on? Was that a open and an open part of the discussion to raise these questions?
Yes, it was part of our discussions as well, and what we should be aware of course, is that even as we think district heating is the most important thing in the world, from a district heating company's perspective, and it was still also important for Facebook to that the energy was reused. This is still a small project in their overall, you can say, investment-wise, and so this district heating project or surface heat project could not, you can say, put them at risk of their main, of course, their main production, which is to store and put data available. So of course we should prove our worth and we should be ready to take the heat and also show that we are that we can deliver on time and on a good quality. So there is of course an element of gaining each other's trust, and also on the other way around, you can say we needed some trust that this is when we invest in something, we should believe that this is a project that has a long time span. But I think we built this trustworthy conversation and got a very good project up and running together.
Good. So some quick questions for you from the chat. Did the project receive any subsidies, and if so, from whom and how much?
Not directly subsidies, but you can say in Denmark we have energy savings credit program where the district heating companies are obliged to make energy savings in the area. So you can say we can, as part of our commitment, we need to make energy savings, and then you can say when Facebook is making energy savings in this project, we buy them from them, and then it's part of it's part of the financing in this project, but we didn't receive subsidies from the outside, no.
No. And how important is that for the business case for this installation, this energy saving obligation part?
You can say the energy saving credits has a good share of is covering a good share of the investment cost.
Okay, good. Then where did the initiative come from? Was it the local government? Was it Facebook? Was it you as a district heating utility? Or who called who? Who started the dating?
So actually it was a little bit before my entrance in the project, but I believe that Facebook was looking at several different sites, and they had a checklist of good infrastructure, a good host, high security supply, and those things. So they came to Odense, also supported by Invest in Denmark and the municipalities. And then the dialogue just got going from there where we showed how much we could use their waste heat and how we could provide them with heat from some of their facilities as well. So I think it was more or less a synergy from early on.
Thank you, Kim, for a second. I promised you Anders will be on, but actually I think I'll just ask the other Kim Schultz. How did you? Was it you who started? Are you the dating agency that made the Facebook and so on meet?
In a way, we were, because we made Facebook aware of the Danish district heating system and the opportunities of making use of waste heat, and they got very interested in that right from the outset. And it was very natural for us. Every time we had a site selection, we also talked to the local district heating companies about the opportunities. And in Odense, they really had some great opportunities of making use of the waste heat. So that was
okay. Thank you. Anders, what did I ask you first? Where did it all come from? How was the discussion formed and so on? Please go ahead if you have comments to that. On you now you can speak, Anders.
Very open.
Can you hear me now?
No, now we can hear you. Go ahead.
Well, I think from a technical point of view, it's important to focus a lot on the temperatures in the system and reduce that lift as much as possible by decreasing the temperature in the district heating system and increasing it on the chilled water side, and also to have this discussion about security of supply. How do you plan on operating the waste heat recovery system? What sort of procedures do you need to have if there is a failure at the heat pump plant? How can the data center cope with that? I think that's some of the key aspects in the early phase of a project like that.
And if there is a failure, what do you do? How do you make sure? My understanding anyway is that data centers couldn't care less about heat if it interferes with security of data supply. Have you comments on how you have worked with them on the risk management? I can see also that Max Peters asked, did the Facebook guys give access to the high security property? And how did you decide on where to put your heat exchangers? Because it is really high security, I understand. Please go ahead, Anders.
Yeah, so in terms of the security, of course, any failure in the heat pump plant cannot interfere with the overall operation of the data center. In this case here, the overall volume of the chilled water circuit is around 1,000 cubic meters, which means there's a lot of thermal inertia in the system. So if there is a failure, it will take a while before the chilled water temperature at the data center will start to increase. And that, coupled with the alarm signal exchange I talked about, means there's plenty of time for the data center to switch back to its own cooling system.
And they have a 100% redundant cooling system, I guess.
Yeah, that's right.
Yeah, so they always have a 100% backup on everything. Good. There's also a question from Claude. I'll just read it out because he sets this COP value at 4.8 to 5.2. Is that for each of the heat pumps, or is it for the group of 3 of heat pumps working in working in series? What is your comment to that?
So the COP of around 5 is for the heat pumps overall, but also for each single group. For the individual heat pump units, it's some of them are above 5 COP and some of them are below, but the average will be around 5.
Thank you very much. then again, you're the technical guy. Andrew asks, is liquid cooling used a lot, or does it cost a lot more in capex? Well, I don't know if it's you, Kim, or if it's you, Anders, because you mentioned, Kim, Jules, you mentioned liquid cooling, but maybe Anders, you also know something about it. Do you have any experience on liquid cooling and capex compared to other solutions? Free to talk. Anders?
Yeah, looking at liquid cooling, I guess I can't speak much about the data center side of things, but looking at the temperatures and for district heating utility, there would be very significant savings on the heat pumps and also on the operating expenses of these heat pumps. So certainly from that perspective, there's a large potential for savings.
Okay. I hope, Andy, that was enough answer for you. Otherwise, come back. And then the question, Ali, I would have asked a little bit later, but let's do it now. For Kim Winter, what is the plan for expansion? What is your next step? And before you answer that, how much of the cooling or how much of the heat from Facebook are you actually receiving? I can remember the number, or maybe you can remind me. But what is the potential overall if you when Facebook have developed further, and what is your plans if you could share a bit on that? Kim, go ahead. Kim Winter, go ahead on that.
Yeah, so basically you should ask Facebook on their plans for expansion. We are ready to take more heat if more heat can be delivered. So basically right now we are focused on getting this project up and running, and you can say it is the largest surplus heat project from a data center. We have as I mentioned, established 25 megawatts and are receiving more than 100,000 megawatt hours. So right now we are focused on getting this up and running, and then we will optimize the systems when we are in a good operation process, and if there is an opportunity for expansion, I think we'll discuss it at that stage. But no firm plans at the moment, to my knowledge.
Okay. Are there any limit in the Odense system? You're Fjernvarme Fyn, but you actually, what we are talking about is the city of Odense. Are there any limits to how much heat you would take from your heat pumps? I know you're getting away from coal by 2025 maybe, but what is are there limits to that, or do you need other heat sources still in the future?
So we have planned to make you can say a stepwise exit out of coal. So we are introducing the heat pumps nearly every year from now on, with first of all this project with Facebook, then the one with sewage sludge I mentioned, and so there'll be a number of heat pumps, and we are still open to take more heat. So this is also an invite. If somebody should show up with more surplus heat, we are always looking to utilize that, because we believe that first of all we should try and find the heat that are in our local area, which we can utilize. So basically the coal-fired unit is 400 megawatt thermal delivering. That's what we need to substitute. But we see it with a mix of maybe 150 to 200 megawatts of heat pumps, and then about the same size of electric boilers. And then right now we're looking at a small wood chip unit as well, 50 to 75 megawatts. So heat pumps will be a considerable share of our future green system, and we can take more heat.
Okay. I kind of ran out of questions now, and the chat did the same. So if anybody have a question for the panelists, it's pretty much now. Maybe Anders, on the expansion plan, maybe you have not been assigned to do it, I guess, but maybe it'll come in the future. But do you have any comments to this heat mix Kim mentioned with heat pumps, electric boilers, and biomass that would be interest for the audience to hear now?
Yeah, as I said in the beginning of the presentation, the plant has been prepared for a future expansion if required by sizing the pipes and leaving room for additional pumps. So that the plant is certainly prepared for future expansion.
So the building itself is prepared to have more heat pumps in the next room when we have access to more heat from Facebook. Actually, Gunnar P. Hansen asked a question.
Just on that, the building would need to be expanded, but the overall design can factor that in.
Okay. I guess that must be to you, Kim Winter, but maybe also to you, Anders. You can both comment on it. Kim, you'll start. Gonna ask, earlier you mentioned heat from wastewater. How much heat will you generate from this source? And I may add, are there any, and that's maybe more for Anders, is there anything that we should really, that makes heat from wastewater more complicated than heat from data centers? Kim first, then Anders.
Yes, so I don't have the exact figure, but it's a little bit smaller than this Facebook project. So it's around 70,000-80,000 megawatt hours. It's about 5,000 households in Denmark we can supply with the heat from the wastewater, where the Facebook project is 7,000 houses. So it is a considerable size as well.
Anders, technicalities in using wastewater compared to data centers, or any other comments on the wastewater part?
Yeah, first of all, I mean, typically the temperature in the wastewater would be significantly lower. That would reduce the efficiency of the plant. And second of all, there's certainly a challenge with fouling in the wastewater heat exchangers and how to keep them clean. But yeah, I think those are the two main things to consider.
Okay. Yeah, I'm guessing that the water coming from Facebook's cooling central is quite a lot more clean than the water coming from the sewage treatment plant, and even more if it's before the sewage treatment plant. Well, we don't want to go down that alley now. Last comments from any of you, Kim or Anders? Otherwise, I will open the discussion. What we'll do now is we'll have the final comments. Then, if somebody's interested, you can continue discussing here on the chat. I will stay on for a while, and then you can just ask questions, and Anders and Kim will try to answer them. Final comments, Kim. What would you tell the audience to do if they have a district heating company and or data center?
Yeah, so if you have a district heating company, I think you should just take your your parallel to the dating community. I think you should get out there and say, what are your plans, and how would this fit in your strategy? Because and you might even, if you have something in our case where we are substituting the coal, you might even have a good offer to this data center that you can take their heat. So I think get out there and tell what district heating is about, and that it's high security of supply, and it's a well-known technology. I think that's also been part of what we have needed to tell some of our the people we cooperate with that they can trust in the district heating, and it's a well-known technology.
Well, yes, I think I'll definitely be I'll be a little bit nervous about inviting my wife out for a date and then only talk about Facebook and data centers and district heating. But I think she has experienced it before, so maybe it'll work again. Any other final comments before we just leave the discussion?
Well, I have one single comment. This is Kim Schulz speaking. So it has always been very important for the data centers to locate close to the power grids. But it's obvious that now it's also important for them to locate close to the district heating grids, so they can achieve this combination of both having sufficient power and making use of the waste heat for heating purposes in the local societies.
Anders, anything? Okay, now I say thank you to Kim, to Anders, and to Kim. Like in any other seminar you are at, there may be more questions, but the three guys will hang around in front of the stage, like if it was a physical seminar you were at, and chat with you and comment on your questions. So if you're interested, stay on. Otherwise, go and get yourself a cup of coffee and wait for the webinar to be released on all the media platforms we can imagine. And thank you for all the emails, and thank you for the 80.9%. It was great, very interesting ratings. That was exactly what we were hoping for. Thank you to all. Kim, Anders, Kim, stay on. And I'll just moderate a little bit. Istak, thank you very much. He says it was a fruitful discussion. Rambo, Anders. Are these cases common in in the Nordics? Can you comment on that, please?
Well, I certainly believe there's a big opportunity to recover waste heat from data centers throughout the Nordics, but provided or depending on the different data centers and their proximity to existing district heating networks. That's certainly a key factor.
Why only the Nordics? Why not Ireland? They have so many data centers. Why not England? Why not the Netherlands? Why not any data center?
I think it all depends on the availability and are there any district heating networks in the proximity? But certainly, yeah, it could be used in a lot of different countries.
I think it's an important discussion for the cities also. Where do we want the data centers? Where do we want non-polluting industries to locate themselves in the future? Do we want them far away on a field somewhere, or do we want them to move closer to cities and where we can actually utilize shorter travel distance for all the employees, but also utilize the district heating networks that we are building towards them? Thank you. So, John 2, does Facebook look for any specific requirements in terms of the water quality returning to the data center? Kim or Anders, I don't know who should take that one, but any of you are welcome.
Yeah, I can take this one. Well, there's certainly a lot of focus from Facebook sides on the water quality in the waste heat recovery circuit, and in fact, on this project, we've used district heating quality water.
So really high level, high quality water, you're using that?
Yes, exactly.
I think we have covered all the questions now, and people are slowly getting out into the coffee break. Charlie, if you have a phone on, then I'll just finalize, because you were so careless to mention that you are in Scotland. Enable microphone, just a second, Charlie. Here you go. Is this something that could be used in Scotland, Charlie? You can speak if you're still there. Maybe he's not. Okay. With that said, this is the end of the presentation. We will stop recording. Thank you for everybody for participating again. There will be more webinars coming up soon. We will have one on pipe networks, and later on there will also be a webinar from Danfoss. And all who have shared their emails will make sure you made aware of these events. And thank you for this, and hope to see you soon out there in the real world. And goodbye.